Hey guys, so this quick intro for tonight's video here. This one's a pretty old video, but I just want to release everything in series as I did it. This here is the refined version. This is the big coil I've been talking about. Right, not what's in the video tonight though. I just want to do this for anybody who might want to replicate this circuit because this has been tested and I've been able to do a bunch of experimenting with the cat bank by charging it, discharging it, and then returning it, and actually making this circuit right here. Actually, I was tuning this circuit right here to get it to be able to return back the power back into the battery, right? So I wasted a bunch of power doing that and everything, and every time I put the power back, I used this bulb. I just disconnect the battery and the cap completely, and then parallel them together with this in series. And anytime it was above 50 volts, 53 volts, it was wasting more than double the power. So there's more than 50% that got wasted when I put the power back into the battery. And this is all documented too. And when I was done, I was able to return the battery to the original state of charge. And that was with wasting more than half of it. And there's only one altercation I did to the circuit is right here. I got a fast reacting diode added right here on the output here. It stops the oscillations in the bank, because what was happening is it was breaking down these diodes here that weren't switching fast enough and allowing AC current to flow, not much, but there was still some trying to oscillate in the cat bank. So it was cutting down on the output. So I added this FR107 right here, just one of them. And that's right there on the red lead going to the bank right there. But this, oh yeah, okay, and this here is the ohms in this big coil. This coil's a lot more you get a lot more potential out of this coil. And it's been tested. I did way more testing with this coil than I did with the other one. The other one I think is still really good to use. It's just that it won't give you the potential that this one has. And here's the scope. And another thing, I don't remember what I said in the videos, but you have to remember that the only power coming out of the battery is the VT right here. The VB is what is returned back into the battery, and the VA combines those two together to come up with your total amperage. So anybody who says that your VA is your amperage total, yeah, you're right, but not in this circuit, because there's only a pulse DC coming out of the top, and that's right here. The rest of it goes in through the circuit, comes back out through the circuit. The stuff on the return is from what came in from the battery the original time, the first time. Then it gets used again on the way out and returned back to the battery. So I just want to say that real quick before I release this video coming up, because it's an older video and I don't remember what I said about the scope, how it's being used. And a lot of people don't understand that the power is going in and getting used and coming right back out, which you can see right here. A big percentage of the power comes back out. I'll just hook this up and you'll see the two LEDs light. It's the same thing in that other circuit. You can't do that. And you can see clearly in this circuit, the top one's a little bit brighter than the bottom one is. That's because it uses a little bit of power, but the overall gains on the output are a lot, like 50% at least. So, and I can show the, you know, here's 62 volts right here. And if I hook this up over here, I think it's still on, yeah. I just go like this. It's the same LED setup. You can see how bright that light is at more than twice the voltage. You know, it's very bright. And the scope shots will confirm that too when I put it on there, but I'm just making an intro here. This can be a long video, but these are good videos to watch if you really want to get into seeing how this stuff works. And thanks for watching. Guys, here's the lights hooked up right there through this meter. And I'm just going to show this, but I'm going to take them off and we'll test the same lights and meter to show the movement. See, I'll put this in the same frame. Keep an eye on the meter and the lights. Nothing. Just took it off. I'll try to put it back on again. There you go. It's on. Take it off. So that's it. I'm going to keep you guys in the frame, one frame, take all these lights off and test it right quickly. Here, put you on the tripod and just bear with me, be a couple minutes just to get it set up. I just want to do it all in one frame so that people can't say it's a different meter or anything. There's a 3-volt lithium battery. Pull this apart. Like, even though those lights are really low current, they still pull a current, and you can see it on this meter. And when you're taking power out and sending it back, that's why it's reading 0 and the lights are still on. And a lot of people should do some research with Jim Murray and Paul Babcock. On that stuff. It's all in the mathematical equations. There's no violation of thermodynamics or anything like that. It is the way it is. Right, see the meter move? Hope you guys can see that in the camera. Try to do it without jerking a bunch of stuff around here, so it's smooth. See it move? And that's just one of the LEDs being lit because they're opposite directions to each other. That's another thing I'll show with this. See? That one's the blue one lighting. I got it on that end. I'm going to grab it over here on this end now. And there. You can see it move. It moves a lot, actually. You know, it's not a little bit. And that's just one of the LEDs at a time. That's the same LEDs I have over here. These ones are soldered on, though I can't take them off, but they're exact same thing. Both the same LED. Bag of these ones right here, 5 millimeter ones. Hey, I'm back. They're all on here now. So what you can see here is the red LED up here. That's power coming out of the battery, and this is the power going back into the battery. These are exact same ones I just showed on the previous clip. The red and the blue right there. And then this one's hooked up the same way, but only the blue one is on. That means power is going in. And that's it. So, and I got a few things too I want to talk about with this circuit. How it is made. so you can compare it to a regular Jewel Thief. I'll bring it up here actually on the screen. But while the computer's loading up and I'm getting that out, I will just getting it to the computer. Sorry guys, should have had this up, but I know people, I've been calling it a Jewel Thief, and that's my own fault. You know, I'm not trying to be a dick to what a lot of people just don't understand this circuit. It's not a Jewel Thief, but I've been calling it one. But let me just bring this Jewel Thief circuit up here. Like, this is your typical Jewel Thief. What you see right here. Right there. You know, and there's resistance that's going into to the base on that circuit. Right, and it would be kind of flipped around where you have this would be over here, your negatives and stuff would be like that on a normal Jewel Thief. But what's different about this is right here. The reason why it's important to have a lot of turns with this is because of this bridge rectifier right here. This is a very important part of getting the power out of the circuit. It's right here. The power is 51 volts. So that, and what I've showed before too, and I should do another demo with this video, but you just have to go look back. And like, you can use a bridge rectifier as a resistor by subtracting voltage. You know, like the voltage that's going through this is getting subtracted. And that's why it's important to have this where it is. It's right here. Whereas normally you have this as your positive on this side, and these are connected together right here, sorry. But when you use a bridge rectifier, it subtracts the voltage that's going through here, and that's why it's important to have a high voltage here, because that's your charging source. It's right here. You know, and this resistor is there to catch the extra current and let it flow through the circuit. That's how it feeds the input battery. It's just like the SERPS device. It's using the power to run the circuit, and then it goes right back into the battery. This light would not be on if it wasn't doing that. It would be just the top one, as they run at different frequencies. And I'll pause this and turn on the clamp meter right here. I don't use this meter. This meter is only here as a reference point. If I see it come up, then I know that there's circuit that's using the power somehow. Like, to measure this stuff properly, you can't like leave your meters on there. You have to leave this thing run for a long time to get the results I'm talking about. You know, and if you're not going to replicate it with the stuff I've got here, well, I don't know if it's going to work for you, because I've never tested it on lead acid batteries. And super caps are what I'm noticing, or where it's at. So I don't know if there's something with the super caps that make it work better or not, but it definitely works a lot better with super caps. So I'm going to turn this back on. And like, even, you know, the battery voltage eventually is going to come down a bit, especially the way it's hooked up right now, because of the LEDs are burning power off. You know, I'll just put this back so it doesn't affect anything. And then I'm going to turn the current clamp on. I'll get it set up here. I'll pause it and I'll set it up. Okay, I'm back here. I got this paused. Current clamp is on there. You know, there's no, it's right there. Goes straight from there to the battery. Into the coil there. So what you want to read on here, and this thing's very accurate. It doesn't affect the circuit like if you try to use the probes won't measure anything. You can't put any resistors in this circuit or anything. You need to use a current clamp to get these results. And the LEDs prove it. It's those, you know, you can light them with your hand. I can go like this and turn them on just like this. Like this is just my body touching that. That's it. You know, that's how little amount of current they take to light. So, on here, I just did a quick snapshot here, stopped it. There's the bottom. That's what's returning into the battery. 4.8 milliamps. And there's 4.8 milliamps coming out just in this snapshot. So every time I do it, something different's going to be. So this time I have 8.7 milliamps coming out and 0.97 milliamps going in. You know, every time I do a snapshot here, it's a little bit different. And it's just a matter of, like this waveform kind of has a big sine wave in it when you expand it out. And that's what you're seeing here. Like, look, 10.7. The bottom is the output. The top is the input. And there'd be plenty of times where I hit it where the top is higher than the bottom. But on average, it's pretty damn equal. See? Top's higher than the bottom here. But I can go along and just take a snapshot anywhere here and get the results. There's the frequency, 20 kilohertz. You know, that's why the LEDs light equally. Like, watch, I'll put them back on again. See, that gauge is 0. Completely 0. Here, off. Still 0. On. 0. It doesn't move because the power is going in and out. That's, and like just this right here, there's no cost to that because it's goes out and comes right back in. You're using the power more than once. It's just like the SERPs device, and that's what this thing is doing. The way that circuit right here is what's going on here. Right here. That sends the power back to the battery. But you can't overload the circuit. Like when you hear that, when I first started this coil up with filling it with capacitance, it pulls like 3 amps because it's filling it and it's not in resonance like it is right now. It's right there. You know, and the blue one here shows the power going into the cap. It's a steady flow of power going into the cap. But it can be tapped right here too with the LEDs. Like, look how bright these are, and they're not making the battery go down. Sure, it is pulling power out of the battery, but it's putting it right back in again. That's the thing about it. It's been sitting at that voltage for over 3 days. It's like a resting voltage for the battery. While this voltage in this cap bank is climbing. And what I've been doing before with the other circuit I've had on here, the other Joule Thief circuit, is I was bringing the voltage up to 60 volts, 62 I think it was. And then I would run a microwave oven bulb, just a normal bulb like this here, 25 watt bulb. I'd disconnect the battery from the circuit, and I would put this in series with, take this cap bank, parallel the cap bank and the battery together with this in series with it, and it would bring this voltage up like 4 points on the very first point there, the ones. That's why I have it on this one cell, so you can get a more accurate reading of what the voltage is in the battery. But you can see right here on this meter, it is fully charged, 26.6 volts. That's the resting voltage for a fully charged battery. And it's been sitting there for days. Well, it has charged this cap bank and dumped the power back into itself while burning power off in this light bulb while I'm doing that. And it's still full. Like the decay voltage on these aren't very much, but there's still some, over time it's going to go down just by sitting. But you can just see right here, it's very, very close to nothing being spent because it comes out and goes back in. And like you can subtract the voltage with a bridge rectifier. It's a really good way of reducing power into a circuit. Like, this isn't a Joule Thief. All I gotta say is try it, because what I'm noticing, the super caps act differently than the normal type of cap, like these 63 volt 10,000 UF caps. The electrolytic cap doesn't act the same as a super cap when it comes to this stuff, so I haven't done enough experimenting with different types of caps. I like using this big bank because when it hits a certain voltage, I know I can bring the battery up a lot with just bringing the battery down like 5 or 6 volts. I can bring this battery up quite a bit because there's over 11 farads in this cap and it's 105 volts. Those are 500 farad caps, and there's 42 of them in series, so you can do the math. It's a lot of power in that bank. And for it to be going up in voltage takes power. Just try to do it yourself. It's not easy to charge that type of a circuit, especially with these protection boards on it. Like, I'm not trying to deceive anybody here. I'm just showing. And like, this is a floating circuit. There's no antenna. There's no ground. There's nothing here that's different. It's just a matter of knowing how to resist power and use it. Because this is a resistor. And we all know what a resistor does. It burns power off. But when you can use it as a resistor and store it in a device, that's exactly what's going on here. People don't understand that the key to this stuff working a lot of times is with resistance and frequencies. But, you gotta do stuff like this. I've been trying to say that for a long time, but, it's hard sometimes. People don't want to even look or understand. And use stuff like this too. You see me a lot of times in these videos, I'm using these meters, but that's not what I base my claims on. These are really good. Like with this circuit, if I just go and do this, see there, look, it just moved. Now it's using power. You see that? But it's putting out a lot more into there. And that all comes down to this bridge rectifier that is it's still using power. Watch. Once I get it right, you'll see that gauge won't move. There, just like that. Put it on here. Nothing, it's not moving. But that's why I use it, is because it's a really good reference. But what happens there, you've seen both LEDs on, right? When I did that, that's because these diodes are breaking down. They're not breaking down, but the frequency at 20 kilohertz is too fast for these diodes. And it's sending power both ways through that cap bank. It's more strong in one direction, though, that what gives it the effect of it looking like it's getting charged. That's what's happening with these diodes. That's why both LEDs were on. But I don't know, it's hard to clarify it. You just have to replicate it. And like I said, I've never done it with lead acid batteries. But it's just something you guys got to try on your own and see for yourselves, because and if you haven't seen what the SERPs is, look up Jim Murray or Paul Babcock. It's not the SERPs, it's working on the same principle. It's using power and then putting it right back into the battery. But thanks for watching, guys.